5.5, the triangle inequality. The triangle inequality theorem says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I pick any two sides and add them together, that number should be bigger than the length of that third side. So if we have x plus y is greater than z, then we also should have y plus z is greater than x, and z plus x is greater than y. So in our example, we're asked if the lengths of two sides of a triangle are 7 and 11, between what two numbers must that third side fall? And what we need to do is make sure that these three inequalities are going to be true. So I'm going to let that unknown side be x, and I want to set up these three inequalities. So I want to show where we have x plus 7 is greater than 11. I want to show where x plus 11 is greater than 7, and I want to show where 11 plus 7 is greater than x. So I want all three of those combinations. All right, so we're going to solve each of these inequalities. I'll subtract 7, so I get x is greater than 4. I'll subtract 11, so I get x is greater than negative 4, which doesn't really make a lot of sense. And then I'll get that that I get 18 is greater than x, which really is the same as saying x is less than 18. Okay, so when I'm saying I really need to take all three of these into account, that x is greater than negative 4, x is greater than 4, and x is less than 18. Well, if x has to be greater than 4, it's automatically greater than negative 4, so I don't really have to worry about that. But I do want to make sure that my x's are bigger than 4, but smaller than 18. So we're going to be between 4 and 18. And that's my answer. The next thing I want to do is determine whether it is possible to draw a triangle with the sides of the given measures. So what I want to make sure I'm doing here is adding two of the sides together and making sure that they are greater than the third side. So in reality, I could check all of them, but as long as I add the two smaller sides together, that's really the only time it might pose a problem. So we're going to add the two smaller sides together and make sure that they are greater than the largest side. So 12 and 9 are my smallest sides, so 9 plus 12. I want to make sure, is that greater than 15? And 9 plus 12 is 21. 21 is greater than 15. We're good, so yes, we can draw a triangle using these side measures. Again, take your two smallest. So 7 plus 23, is that greater than 26? 7 plus 23 is 30. So absolutely, we're in good shape here. Yes, we can draw a triangle. Again, 9 plus 10, is that greater than 20? Well, that's 19. Is 19 greater than 20? No, it's not. I can't form a triangle. If I tried to connect these three pieces, they're never going to reach. All right, in 4, we've got 8.5, 6.5, and 13.5. So again, I'm just going to add those smaller ones together, and I want to make sure that is greater than the largest side. So that's going to give us 15 is greater than 13.5, which is absolutely true. So yes, we can draw this triangle. 28 plus 47 is greater than 70. Let's double check. Is 75 greater than 70? Absolutely, we can draw this triangle. And then we have 28, 41, and 13. So again, your smallest sides, is that greater than 41? So that's going to be 41 is not going to be greater than 41. That's equal. So no, that also will not draw a triangle. All right, lastly, we have that the measures of two sides are given. And then again, between what numbers must that third side be, which is what we were doing before. So we want to set up our inequalities. So we have, we'll use 9, 15, and x as our third side. So we want to make sure that 9 plus 15 is greater than x. We want to make sure that 9 plus x is greater than 15. And we want to make sure that 15 plus x is greater than 9. All right, so 9 plus 15, that's going to give us 24. Or we could rewrite that as x is less than 24. When I subtract, I get x is greater than, and that's going to give me 6. And then here, when I subtract, I'm going to get x is greater than negative 6. And really, it's the negative we can kind of ignore. It's not going to help us in any way. All right, so we want to make sure x is bigger than 6, but also less than 24. All right, next one. So we, again, are going to use x as our third side. X plus 11 needs to be greater than 20. We want to make sure that 11 plus 20 is greater than x, and we want to make sure that 20 plus x is greater than 11. All right, so we'll subtract 11, so we're going to get that x is greater than 9. 11 and 20 is 31, is greater than x, which means that x is less than 31. And then when we subtract here, we get a negative, so we don't have to worry about that. All right, so we want to be between 9 and 31. And lastly, again, our third side is going to be x, so 23 plus 14 has to be greater than x. 23 plus x has to be greater than x. Has to be greater than, not x, 14, that third side. And then 14 plus x has to be greater than 23. So that's going to give us 37 is greater than x, or that x is less than 37. This will give us that x is greater than negative 9, which doesn't really do anything for us because it's negative. And this will give us that x is greater than 9. So it's going to tell us that we need to be between 9 and 37.